Welcome to the deep dive. Today we're really getting into Android Jetpack. Think of it as your fast track to mastering modern Android development. It's this toolkit, right? Designed to make app development simpler, help you write clean, solid code that, just works. We'll be looking at view models, state flow versus LiveData, room for persistence, WorkManager for background stuff, and even testing strategies. Basically a shortcut to the essentials.
Exactly. And it's not just about what these are. We want you to get why they matter, why they help build better, more maintainable apps. It's about understanding the architectural wins you get.
Okay, let's kick things off with view model. I sometimes call it the UI data guardian, its main job. Storing UI data so it survives things like screen rotations, configuration changes.
Right.
This makes the UI stable, stops it from resetting unexpectedly. It feels more solid to the user.
And the clever part is how it manages its life cycle. It uses something called a view model store that's tied to the activity or fragment. It only gets cleared out, destroyed, when that activity or fragment is gone for good, not just temporarily like a rotation.
That persistence is key. So building on that, what about sharing data? The shared view model concept seems
Right.
really handy when you've got, say, multiple fragments in one activity that need to talk to each other.
Well, absolutely. That's a common use case, and it's pretty straightforward. Instead of using the view model's delegate, you use activity view model. So
Oh.
you'd write something like val view model, shared view model by activity view models. That tells Kotlin to grab the view model scope to the activity, not just the fragment. So all fragments using that get the same instance.
Got it. Simple switch, big difference in scope. So view model handles the data surviving, but how does that data change? How do we manage its state over time?
Yeah.
That leads us to state management, and live data's been around for a while. It's observable, life cycle aware, only tells active observers when something changes. Pretty efficient.
Yeah, and a key detail with live data, something that trips people up sometimes, is the difference between set value and post value.
Right. Main thread versus background thread.
Exactly. Set value, you got to be on the main thread. If you try from a background thread, your app's going to crash. But post value, that you can call from anywhere. Like after a network request finishes on a background thread, it handles posting the value back to the main thread for you safely.
Okay, so live data works. It handles the thread switching with post value. But then there's stateflow. It feels like stateflow is everywhere now in modern Android. How do they really stack up?
Yeah, that's a big question for developers now. Stateflow is part of Kotlin coroutines, which themselves are a huge part of modern Android. Coroutines just quickly let you write asynchronous code that looks synchronous. Much cleaner, easier to read, helps keep the UI responsive.
Right, essential stuff.
So comparing stateflow and live data, there are a few major differences. First, lifecycle awareness. Live data has it built in. It just works. Stateflow, nope. It's not inherently lifecycle aware. You need to manage collecting it within a lifecycle aware scope, usually using something like lifecyclescope.launch when started or the repeat on lifecycle API.
So a bit more manual work with stateflow there.
A bit, yeah. Second big difference, coroutine support. Live data doesn't really play nicely with coroutines directly. You need wrappers. Stateflow is coroutines. It's built on them, fully integrated. Big win for Kotlin first development.
Okay. And use cases.
Well, live data is primarily designed for the UI layer, observing data and updating views. Stateflow is more general purpose. You can definitely use it for UI state, but it's also great for representing state in lower layers of your architecture, like repositories or use cases. It's more versatile.
So choosing between them really impacts your architecture, especially if you're heavily invested in coroutines.
Definitely. It's a significant architectural decision.
Makes sense. Let's maybe zoom out a bit then. We've talked about view model, live data, stateflow. These are all parts of Android Jetpack. How would you define Jetpack overall? It's this whole suite, right? Navigation, WorkManager, room, lifecycle, view model.
Yeah, it's Google's collection of libraries, tools, and guidance to help developers follow best practices, reduce boilerplate code, and write high-quality apps more easily. The main benefits: less repetitive code for sure, but more importantly, it pushes you towards better app architecture. Things like separation of concerns, making your app easier to test and maintain.
And you mentioned lifecycle scope earlier when talking about stateflow. That seems like a perfect example of Jetpack tying things together. It's a coroutine scope linked directly to a component's lifecycle, like an activity or fragment.
Exactly. It ensures that any coroutine you launch in that scope is automatically canceled when the activity or fragment is destroyed.
Which prevents memory leaks and wasted resources. Super important.
Absolutely. And Thinking about moving between those lifecycle owners, those screens, Jetpack's navigation component helps a lot. But even a small detail within fragment transactions, like using add to backstack,
Right.
is crucial.
Right, so the user can actually go back.
Yeah, without it, pressing back might just exit the whole app, which is usually not what you want if you've navigated several steps deep within a single activity.
Yeah.
It makes the back button behave predictably.
Okay, let's shift gears to data persistence. Room database is a big one here, especially how it works with Kotlin coroutines now.
Oh, it's a game changer. You can just mark your database functions in your DAO, your data access object, with the suspend keyword, like add query, select from user, suspend fund get all, list user. Room handles running it off the main thread for you. No more callbacks or managing your own thread pools for simple queries. It's clean.
And it goes beyond just suspend functions, right? You can use Kotlin flow too.
Yes, and that's incredibly powerful for reactive UIs. You can define a DAO function like add query, select from user, fund get users, flow list user.
So that flow emits a new list whenever the user table changes.
Exactly. Room watches the table, and whenever data is inserted, updated, or deleted, it automatically pushes the new list into the flow. Your UI just collects this flow and updates itself. Real-time updates from the database, pretty much automatically.
That's awesome for relational data. But what about simpler stuff like user settings or preferences? We used to use shared preferences for that.
Right, and shared preferences had, well, it had its issues. Blocking I/O on the main thread, lack of type safety, potential race conditions. That's where Jetpack Data Store comes in. It's the modern replacement.
And what advantages does data store bring? I know it's supposed to be better.
Several big ones. First, it's fully asynchronous, built on coroutines and flow, no more blocking the main thread. Second, type safety, especially with Proto Data Store, which uses protocol buffers to define your data structure. You get compile time checks, fewer runtime errors.
Protocol buffers,
Yeah.
right, for structured data. Is there a simpler option?
Yep, Preferences Data Store. It's more like shared preferences, using key value pairs, but still gives you the async benefits and some type safety through specific key types. Much safer than shared preferences.
So whether it's complex database stuff with Room or simple key value pairs with Data Store, Jetpack offers modern, async, safer ways to handle local data.
Precisely. It makes your data layer much more robust and performant, fitting nicely with coroutines and reactive patterns.
Okay, cool. Now, another often tricky area, background work. Tasks that need to run even if the user leaves the app. WorkManager aims to solve this.
It does. WorkManager is designed for background tasks that are deferrable, meaning they don't need to run right now, but also guaranteed to run eventually.
Like what kind of tasks?
Oh, common examples are syncing data periodically, uploading logs or analytics, applying filters to images in the background, things that should happen but can wait for the right conditions, like network access or charging.
You mentioned periodic work. Is there a limit to how often you can schedule something?
Yes, and this is important. For a periodic work request, the system enforces a minimum repeat interval of 15 minutes.
15 minutes. Okay, so you can't use it for, like, every minute updates.
Correct.
Yeah.
If you need something more frequent, WorkManager probably isn't the right tool for that specific job. It's designed for less frequent, more resource-conscious background work.
You also said it guarantees execution. That sounds like a strong claim. How does it manage that, especially if the app gets killed or the phone reboots?
That's really the core strength of WorkManager. It's quite sophisticated under the hood. It doesn't just use one single mechanism. It actually picks the best available API based on the device's Android version. On newer devices, API 23+, it primarily uses Job Scheduler. On older devices, it might fall back to Alarm Manager and broadcast receivers.
It adapts.
It adapts, yeah. It manages constraints like network availability or charging status. And crucially, you can mark your work request with set persisted, true. If you do that, WorkManager stores the request and ensures it gets rescheduled and runs even after the device reboots. That's how it delivers on that guarantee. It's really reliable.
That's impressive. Okay, let's wrap up the technical part with testing. Modern Android apps with view models, coroutines, flow. How do we effectively test this stuff, especially unit testing view models?
Right. Testing is crucial. For view models using LiveData, the key thing you usually need is the instant task executor rule.
Why that rule specifically?
Because LiveData uses Android's main looper for its operations, even when you use post value. This rule swaps out the background executor used by the architecture components with one that executes tasks synchronously, making your LiveData tests predictable.
Okay, and for the coroutines part, if the view model launches coroutines,
There, you'll typically use the testing utilities from Kotlin's coroutines test. That library provides test coroutine dispatcher, though it's being deprecated, and, more importantly, the runtest builder. Runtest gives you a scope where time is virtualized, allowing you to control the execution of coroutines, skip delays, and make assertions deterministically.
Makes sense. So what about testing view models that use stateflow instead of live data?
Similar principles apply. You'll still use runtest to control the coroutine execution. For observing the state flow itself, you can either collect it directly within runtest using standard flow operators like first or toolist, or you can use a dedicated testing library like Turbine.
Turbine.
Yeah, Turbine provides some nice helper functions to make assertions on emitted values, completion, or errors from a flow in a more structured way within your tests. It simplifies checking the sequence of emissions.
Okay. And a slightly different angle, but still related to dynamic app behavior Firebase remote config. How does that fit into making apps adaptable?
Remote config is super useful. It lets you change your app's behavior or appearance remotely without needing to publish a new app update. You define parameters in the Firebase console, set default values in your app, and then you can fetch updated values from the backend.
Like feature flags or tweaking UI elements.
Exactly. Feature flags are a classic use case. You might fetch a Boolean flag like is new feature enabled. You typically set defaults in your app using something like firebase.remoteconfig and then config.setDefaultsAsync, r.xml.remoteconfigDefaults. Then you fetch the latest values.
So testing ensures reliability, and tools like remote config add adaptability. It all contributes to better apps.
Absolutely. Robust testing gives you confidence, and dynamic configuration gives you flexibility.
Wow, okay. That was a really thorough tour through some key Jetpack components. Let's try and summarize the big takeaways for everyone listening. First, view model. Seriously, it's your data's best friend across configuration changes.
Yeah.
Keeps that UI stable.
Mm-hmm.
Second, stateflow versus live data. Lean towards stateflow in modern apps. Better coroutine support, more versatile, even if it needs a bit more setup for lifecycle.
Right. More future-proof generally.
Third, Room plus Kotlin Flow. Fantastic combo for reactive database access. Data changes, UI updates automatically.
Super powerful.
Fourth, WorkManager. Need background tasks to run reliably, even after reboots. WorkManager is your answer. Guaranteed, persistent execution.
The reliable workhorse.
And finally, testing. It's actually gotten easier and more robust with tools for coroutines and flow testing like Runtest and Turbine. Makes building dependable apps achievable.
Definitely. The tools are there. So, maybe a final thought to leave you with. Now that you've seen how Jetpack components can simplify really complex problems, things like lifecycle management, background execution, reactive data, maybe think about one feature in an app you've worked on or one you're planning. Could you refactor that tricky data flow using Room and Flow to make it smoother? Or could you use WorkManager to finally guarantee that critical sync operation always completes no matter what? How can you leverage these tools to elevate your own app's architecture and user experience? Something to chew on.